Assalamualaikum and very good morning. So our next tutorial are related to shell plane and assembly. So basically we will have a horizontal and vertical plane here as described in this figure with a dimension of a horizontal line is 400 and vertical is also 400 while the thickness for both are 4 mm. And for this case the materials for both plate are structural steel. Okay, and the connection between the two bodies, okay, as stated here, line here as the connection part. Okay, and also this is the mesh, and this will be the loading fixed at the bottom support and apply force at x direction with 1000 Newton. Then we will proceed to the results. Okay, so yes, as usual, click for static structural. Okay, so as we only consider one material, so we can proceed to the geometry. So click design modeler. Access. While waiting, refer back to the tutorial. So this will be your model 400 mm. Okay, so first we decide which plate we want to proceed. For my case, the first plate will be at the x and y plane. The second part will be the x and z plane. Okay, so first we proceed to this plane first, xy plane. So this is what we will proceed. Okay, if you like to draw at the plane view, you can click here. Okay, but I prefer as usual, so isometric view. Okay, so when you decide to draw at the respective plane, so we can go to sketching. Okay, as our plane, we can proceed to rectangle. Click rectangle. Before that, change the unit to millimeter as usual. Okay, so then we can proceed to the rectangle here at this direction. Okay, so then go to dimension, general, okay, fix to horizontal and vertical. So ours is 400, horizontal and also vertical is 400. Okay, so close up. So this is our model. Okay, so back to modeling. Okay, before that, if you like to have a grid, you can click here, grid, show the grid. Okay, or snap, it's up to you, but I'm not prefer to use this, never mind. So back to modeling. So now we have the sketch, so we have to declare this as the plate. Okay, so to do that, go to sketch first. Okay, and go to concept. We want to create the surface from sketches. Okay, click here. So currently we already picked the sketch at xy plane. Okay, so we can apply. Okay, so you can declare the thickness for this sketch is 4 mm, right? Okay, just enter, then generate. Okay, so this is our first plate. Okay, so then we want to proceed to the horizontal part. Okay, so this time we will consider the x and z plane. Okay, so by that, this is xz plane. Click here. Okay, then go to sketching. Okay, again, draw the rectangle here. Okay, so you have like this. You can put anywhere first. Okay, then go for dimension. Okay, this is again 400. Sorry, 400. Vertical lines is also 400. Okay, then the same procedure, go to sketching. This time we proceed to this one. Okay, want to declare this as the plane. Okay, so go to concept. Sorry, click here first. Go to concept. Okay, surface from sketches. Okay, and we pick this one, apply, then again the thickness is 4 mm, enter, and generate. Okay, so generate, then generate. So it's not working properly, so double check. Okay, we can delete it first. Let's redo. Okay, so now we want to create a surface from sketches. Pick the second one. Thickness is 4 mm. This object. This is this one. Then we apply. Sorry, sketch 2. Then we apply. Okay, then generate. Okay, let's see. For part consists of this. Okay. Okay. You can see that we have problem to generate. Okay. For this model. Okay. Why? Actually, because we have to change the operation to add frozen. Okay. So change to add frozen, then click generate. Okay, so now you have two parts and two bodies which represent the vertical and also the horizontal part. Next, we proceed to the constraint. Next, we proceed to constraint, but for constraint, will not conducted in the design modeler. So we proceed to mechanical module. But before that, okay, return back to the main part. Okay, if you want to add some materials, okay, as I mentioned earlier, you can click at the engineering data. Okay, enlarge. How to add the material? We can go to this part, string data filter, string data source. Okay, we can add material here. For example, click. We have different materials. Just for example, we want to add a stainless steel. Just click here, add. So we will add this stainless steel, or maybe titanium alloy. Would add here. Okay, so return back to this. Okay, now as I mentioned, we want to proceed to the mechanical module. Okay, just click button here. Okay, still waiting. Okay, so this is our model. Okay, if you notice a few changes that we have made, okay, to rotate this, you can click here. For example, we have two different surface. Okay, you click here. Okay, remember just now we add frozen, so we have two different model. Okay, I think we can rename this. Okay, can rename. Okay, for example, just name it as the surface 2. Okay, so previously I've showed to add some materials. Okay, so you notice that we have several material here. Okay, back to this. Okay, if you pick the surface body, we can automatically by right. Okay, as we proceed with the surface, it is a shell element. Okay, from here, if you notice, automatically it will assign as this structure steel. Okay, if you want to make changes, for example, you can directly pick the material that we have declared before, for example, stainless steel and so on. Okay, it's changed to stainless steel. But for this exercise, we proceed to structured steel for both part. Okay, so although for surface body number 2, we also maintain the same materials. Okay, next, okay, before we proceed to the connection, we can click the mesh. Okay, click mesh, then by default we can directly generate, right click, then generate mesh. Okay, okay, so this is the mesh. If we, it's set by default. Okay, if we satisfied with this, we can proceed. But if we want to change, there are few way to change. One of them is by changing the size here. Okay, for example, it is 5.0 times 10 negative 2. If you want to change this, for example, you can reduce to 0.025. Okay, because the size in meter, if you enter, okay, maybe it's no changes, 0.05. Okay, sorry, enter. We can, sorry, I think it's too small here, 0.02. Then go, then generate mesh. Okay, we get smaller meshing. Okay, next we can proceed to the boundary and loading conditions. Okay, as usual, right click, go to insert, so fix support at the bottom. Okay, click geometry, fix support. We apply the bottom part, click line here, so here, and apply. It is a fixed support. Okay, while for force acting, okay, refer back to the exercise. Okay, the force at this point. Okay, so the force, right click, insert, it is a force. Where is the force? Force acting. So we want to find a point, click point here, so it is stated here, and at Z direction. Okay, it depends on your drawing. For this case, it is at X direction, so magnitude here, click, sorry, for vector, click coordinate, component, sorry. Okay, we want to change at Z direction, it is 1000 Newton. Okay, enter, selection, okay, sorry, it is here, and apply. See, okay, refer back to the tutorial, it is at this direction. Okay, so ours is here, make some movement to have this one. Okay, so actually we complete almost all, but we still pending for constraint or the connection. Okay, okay, to conduct the constraint, we have to declare. So by that, go to coordinate system. Okay, it seems like we want to merge between surface number 1 and surface number 2. Okay, right click, go insert, sorry, not coordinate system, it's a connection. Right click, insert, go to manual contact region. Okay, so we have two part here. Okay, so for the contact, we want to select the first one, surface number 1, while target surface number 2. But for the contact, we don't want to select the surface. Actually, we only want to pick the edge here. Okay, so by that, just click contact here first. We want to select the edge. Okay, so if we go to here, there is a possibility either this edge belong to surface number 1 or surface number 2. Okay, to make sure that we pick the appropriate part, the right part. Okay, so we must first hidden the surface number 2. So how to do that? Just click here, right click, hide body. Okay, so back to our connection. Okay, we pick the edge. So this is contact, this is our selection. Then apply. Okay, while for the contact bodies, we want to connect with the surface. Okay, but we have hidden the first one, so we change. We show body. The first one we can hidden. Hide body. Okay, so either you want to choose the edge or you want to pick the surface. Okay, so both are possible, but for this case, okay, I want to pick this one. Okay, sorry, go to this part, target, surface, then apply. So then we have a complete. Okay, so if we go to the show body, so we have the complete model and we fulfill all the requirements: geometry, material, connection, mesh, and so on. And also for the loading and boundary condition. But for the results, okay, we can choose the result that we desired. For this case, as usual, minimum we go for total deformations, and we can also go for the stress, Baumeister stress in general. Okay, or maybe you would like to have the strain. Okay, maybe equivalent strain. And it's okay. So I think we complete all the requirement, then click solve. Okay, just wait until you get the results. Okay, allow access. It depends on your PCs. Okay, 10%. Okay, then you get the results here. Okay, so this is the equivalent strain. We can click for stress, which is almost similar, and also the total deformation. If you need another results, just pick it here, insert. For example, deformation, stress, you want a maximum principal stress, shear stress, normal stress, and so on. Then rerun, then you get more results. Okay, so that's all. So good luck for your exercise. Thank you.